The cloud, thank you very much for reminding me about that. That's right, because Melissa for sure will probably want to watch it.
Thank you.
Thank you. Great.
Okay, do you see my sharing?
Yes.
You should see now my PowerPoint.
Yep, looks good.
Okay, so I'm gonna start. Okay, hi everyone, I'm Salvatore Tramuto, and I'm an undergrad student studying at the third year of the University of Palermo, studying physics. And today I'm gonna make a tutorial of the use of the portal aspect of the Rubinstein platform, and in particular also an application to young stellar object, which is my research topic that I've done in my internship report. So here's just a review of what you're going to obtain following my tutorial. This is just a screenshot of the portal aspect with some plots in it. And this is obtained using not DP0 data, but data of Venuti et al. 2014. But after a very brief look at what I've got in my report, I'm going to do a tutorial with DP0 data, so you can follow me with that and obtain the same things. So there's an outline, just the main topics of this presentation. At first, I'm going to tell what I've done in my internship, so just the main points, and the treated topics, in particular young stellar object, accretion of young stars, and the classification of Titori stars. After that, I'm going to focus on the portal and notebook aspects, and concluding this first part of the presentation, I'm gonna with the core of it, which is some live applications. At first, I'm just gonna show you my results of the internship report with the portal aspect, and after that, we're gonna start with the real tutorial of the use of portal, and it's a step-by-step tutorial. So if you wanted to follow me, you can do that. Really quickly, what I've done with my report, with my internship, I worked with photometric analysis of young stellar objects, and the main things that happened during my internship, which was on the last month of 2021 and the first of 2022, are that I became a member of the Transient and Variable Stars Science Collaboration, TVS, which is a very large science collaboration which deals with a lot of astronomic topics, and in particular working with Sara Bonito, I dealt with short-term variability young stellar object in the context of the activity of TVS DP0 task force. After that, I participated to the Stack Club meetings that occurred during my internship period. The Stack Club meetings were very, very useful because I managed to understand the concept of the notebook aspect and the use of the metrics, and more deep understanding of the use of metrics was possible attending to the second survey cadence optimization committee, the COC, where the use of metrics was for the optimization of the survey strategy. And in the end of my internship, I made a report. So this is the one I'm going to show you in this first part of the presentation, just the end of it. And if you wanted to have more details about that, in the breakout room or just in the main after this presentation, I can go more in depth with that. And this report is available on my GitHub. So really quickly, just a brief look of my research topics within TVS. The main thing that I work with are young stellar clusters, in particular for the accretion process of the young stellar objects, and their classification, in particular of Titori stars, in classical Titori stars with client Titori stars. So the young stellar objects can be classified in 4 classes using the spectral energy distribution. The class 0 is where we have just the protostar, and it is surrounded by gas and clouds, and the black body radiation component in the spectral energy distribution is almost 0. In the class 1, we have a more developed protostar, where we are seeing that an accretion disk is starting to form. So we have a great part of UV emission which is starting to form. And in the class 2, we can see the disk that appears more and more flattened, and can appear the accretion process, because also it follows with the warming up of the cloud by the star. In the class 3, we don't have any more disk, and probably the watery remains of the disk has formed planets, or it was all consumed by the accretion process if it happened. The T-Tauri stars, which are the main topic of my research in my internship, are new young born stars, and they are characterized by irregular brightness variations. You can study that with the light curves, and in particular they can be found in young stellar clusters, and in particular with NGC 2264, which is the one I studied in particular, following the study of Venuti in the Venuti Talk 2014. In particular, these two plots on the right represent the spectral energy distribution, the upper one of a classical T-Tauri star, and the down of the weak line T-Tauri star. And they have those colored arrows that mark the Rubin LST filters that also mark the UV axis, which is a characteristic of the classical T-Tauri stars, because the classical T-Tauri stars have an accretion process that produces UV axis emission, but also the presence of the disk causes an infrared axis emission. Both of them lack in the weak line T-Tauri stars spectral energy distribution. Indeed, we can see that there are no axes in the UV and infrared bands. So this is it for just a brief look of my topic, the science topic I dealt with. And we can go to the application to the Rubin Science Platform. So what is the Rubin Science Platform? It's just a digital platform that is used by the scientists of the Rubin LST to access the pipeline, which contains the simulated data and in the future, the real data of the Verasi Rubin telescope. Here you can see on the down and right as just a screenshot of the opening page of a Rubin Science Platform, where we have three aspects. In particular, I worked with the Portal 1 and Notebooks 1, of which you can see two screenshots, just as I said, of the opening pages. And now we can essentially go to my applications. This is a screenshot of my report. At first of the notebook, using in particular Bokeh, which is a library of Python, and to generate plots that can be which we can make a comparison with plots generated by the Portal aspect. Indeed, as I said, this is the same picture I showed you at first. We are gonna obtain these plots in the Portal aspect. And at first, I'm going to show you the comparison between these plots and the one I obtained in the notebook. So I'm going to end this slideshow to go to the to my notebook, and this is the report. So just the end of it. So as I said, I'm going to go real quickly with this. I'm not going to talk about the codes. If you're interested in the second part, we can talk about that more in depth. And what I've done, essentially, I made two color magnitude diagrams of the data points in NGC 2264, the various stars, using Bokeh, which make me do multi-plot linked graphs. If you go down, we scroll with this is the filters of the Rubin LST filters, and here's the part I made a screenshot. We have here just a screenshot of the Portal of the of the plots I made, but using this link, I can use the real power of bokeh, which made interactive plots. So if I drag my mouse in these points, I can select them. The same points that there's selected are going to be selected in the other plots, or we can use other buttons, for example, the lasso select button, to grab some points, and these points are going to be highlighted also in the other plots. Going quickly also with that, we can see just the comparison with these two plots. We have in the first one, the plots they obtain using the notebook, where I applied a filter using selecting only the higher values of color indexes U minus R. And the points that are highlighted, as I said, are the same ones in the other plots. Why I highlighted those points? Because I thought that classical theta stars are characterized, as I said, by accretion. The accretion is marked by an view axis, so the emission have an axis in the U band. On the other hand, the weak line theta stars don't have this axis, so they're probably gonna have an higher values of the color indexes U minus R. So I just selected the right ones, and I made this way a comparison with these plots that are obtained using the portal. And as you can see, there is a correspondence between both. What I marked in these points, essentially, I can show you right now because I prepared the portal in this way, and I'm gonna go more in depth about that after this real quick view in the tutorial. But essentially, in the Venuti Talk 2014 article, we can see that has been made a classification between classical and weak line theta stars by other means. So I have this column that classify those stars. So if I apply a filter choosing the weak line theta stars and leave those filter, take this out to see all the things. I'm going to show you more in depth these things after this, and remove the filter. I obtain essentially the same thing, that the weak line theta stars, and we are sure that these points highlighted in yellow are weak line theta stars by other means, are the ones that have higher values of U minus R, not having because they don't have the accretion process. So this is just it for my start of the presentation. So now we can go to the tutorial part of this presentation, and we're going to go to our speed up search, which is just the entrance page of the portal aspect. So if you want to follow me, you can open it now, and I'm going to give you some time with that. And we're going to start looking at all these windows. So at first, we see the select tab service. What is tab service is a table access protocol, and contains all of these sets of simulated and not only simulated data. In particular, to work with DP0 data, we have to choose the LST RSP. You can click that. So if it is highlighted with green, you can see that is selected. After doing that, there's the second point. Second point is select query type. There are the first one, which is pre-selected. It is a single table. Single table, it is essentially what you see on the center of the screen. But there's another one, which is edit EQL, which is, as he said, advanced, that made you write the codes to have more in-depth control of what are the filters we're applying, the constraints, and the table you're using. But as the user I have with this portal aspect, I prefer using the single table one, which is the standard one. Or we can continue. We have the third point, which is select table. At first, we have to select the table collection, the schema, and you may have different columns than mine, but I choose one. You should have two. which is DP0 DC2 catalogs. So if you choose that, you have chosen the table collection, which contains many tables. And in particular, you have to choose the first one, which is DP0 DC2 catalogs.object, which is also the pre-selected one. So focusing on the fourth point, enter constraints. On the table, we see that there are a lot of columns. Many of them are pre-selected as these ones, and the others don't. They are not pre-selected. So you can use this button to select all these points, every point in the column, and right-click that to deselect all of them. This is because I just wanted to make some columns, just the one we used they let you see in the screenshot, so we can make similar plots with DP0 data. We have to choose many columns. What do we choose? Essentially, obviously, rate ascension, which is indicated by A, and declination. And we have to choose the magnitudes in the various filters. Now, there are many ways to do that, but I prefer one, which is using this unit column. There are many columns in this table, which stands for many things. In particular, unit gives the unit of the physical variable that we are working with. And this window right there makes you apply the constraints, the filters. In this case, for the units, made you choose the unit you want to see. If you click on this arrow, it opens a little window with all the units that are available in this table. In particular, you want to select mag, which stands for magnitude, to select only the columns that have magnitude unit, and apply filter, clicking on filter or just pressing enter, so that we have, as you can see, all columns with the mag unit. You can see also that this window appeared in mag with this particular grammar. You can also type that if you know how to use the grammar. How you can do that? There's a way that show you the grammar, which is just pointing the mouse in these windows, these white windows, and standing it some time. It just show you all the values that you can insert. And for example, in the second line, we have to choose in followed by commas if you wanted to take many filters, but using just one, we have in. It has to have mag in it, so it follows only the mag unit. You could also choose for the name, entering that on the filter of the column name, but as you can see, they have various names. For example, we have 2 names for magnitude G because we have 2 values of that, and so this is not very useful if you don't know how the columns are named, but you can use the unit one, which obviously is defined. Another way to help you with the search of columns you want is to use the description. The description part gives essentially a description of the column you are seeing in the left, and in particular for this magnitude, we can see that for each filter we have 2 values. In particular, I want to show you the MagC model one, and in general all the MagC model ones, because I tried. There's not a real reason, but I tried with both of them, and using MagC model is quicker than using the Mag and various filters. So to follow me quickly, it's useful to use the C model ones. So we're going to take, for example, MagGC model, MagRC model, and MagUC model, which are the ones I showed you in the screenshot in the presentation. So you could just continue, but if you want to return to the table containing all the columns, you can click on this remove one filter button. So it's gonna remove this filter on the unit and return to all the columns, the table with all the columns where we have the max, and scrolling up also right ascension and declination. Now, going to the left part of the screen, we see that they are pre-selected these columns of right ascension and declination to have a special distribution of our data. Now, what we have to select, shape type, which is the shape of the query we are going to make. The pre-selected one is cone, where you have just to enter the center of this cone, or there is polygon. Polygon makes you enter the coordinates or the vertices of this polygon, which is analogous of the cone one. But using the cone, we have to enter the coordinates or object name if we have, for example, as it said in the example, and you see if it's present on the query. But for example, we're going to take the coordinates 60 and -30 that I tried, so it should work very quickly. And after that, we have the radius of this cone. We can make it bigger, for example, 100 arc seconds. At this point, we have to go on the lower part of the screen. There's just the search button, the cancel button, but you also have the row limit. The row limit is pre-selected as 50,000, but if it takes you a lot of time to run, you can take fewer data, for example, 10,000 or less, to have a quick look, because for what is my work with the portal, I use it as a quick look of the data, and after that I work more deeply using the notebook. And for what you need, essentially you can take less data, but you should be able to search for 50,000 row limit. It shouldn't be that long to take. So we are starting the run, and so this is what you should obtain. So there are three main windows in this page. The first one, if you click on coverage, this is one with I didn't work with a lot, but just if you click coverage, should let you see all the data with the background in it. But we are not going to focus on that. We are going to focus on these two. This is the plot one that we are made with the right ascension declination plot, and the table we are selected with the columns we have selected. So the standard look at the portal should be like that, but there are other ways you can see the portal you're working with, and you can see that I'm gonna move this one over there using these buttons. The pre-selected one is tree view, which is this one, but there are others. For example, image table lets you see only these two, image X and Y, only these two, but the last one, which is the one I'm interested in, is X and Y table. So just click X and Y table to see with this page. On the upper part we have the plots, and on the lower part we have the table. So to obtain a similar thing that the one I showed you at first, we have to make more plots. How do we make more plots? We have to select this button on the upper left, add chart. Clicking on add chart, it should pop up this window. So you have to select what are the columns we are going to work with, particularly the X and the Y axis. For example, starting with the color magnitude 1, we had R versus U minus R. And for the Y axis, we have to look for the magnitude R column. To do that simpler, we have to click on this lens. Clicking on this lens should open you this window with all the columns you have selected in this query. So you can just select the mag R C model 1, press on OK, and so you have this mag RC model. On the X1 is just a little bit more complicated because you have to select, you have to do U minus R, so you don't have just to select one columns, but two, and made an operation with that. How you can do that? You can just search for the first one, which is U mag, so mag U C model, and press OK, but we have to take minus the mag R. So you can select this one, copy that, and make minus, paste it, and you should change mag U with mag R. Doing this way, you have mag U C model minus mag R C model. After that, we can see that there are many ways to customize your plot. At first, I didn't mention this plot type, which is as you may think, scatter, the one we are working with, but you can also make heat map and histogram. After that, you can choose the type of error, both x-axis and y-axis, that could be symmetrical or asymmetrical. And the trace style, I chose point, but you can also make lines or connected points by lines. Now we have two kinds of other options. The first one is trace options. Trace options modify the look of your graph. At first, you can choose the symbol, the type of symbol. The pre-selected one is circle, but you can take, for example, circle open, which is just the circumference, or other, for example, I can take square. After that, I can choose the color, and pressing on the lines, you can see all the colors available. For example, I can take the red one, press OK, and you should have this one. After that, there's color map and color scale that I quite didn't use, but essentially make you have a gradient of colors, for example, gradient of grays for a selected column. You have to select the column using the lens, and I'm not going to do that, so I'm going to click on the X and select the type of gradient. So in this case, it's grays, but there are many others. And after that, you can choose also the size map, which is the size of the points of the plot. You can make it standard to not have bigger points. After that, we have chart options. Chart options contain the chart title. You can make very quickly color magnitude, just to remember that. And the label for both X and Y axis. In the X axis, we have U minus R, and Y we have R. Here you can see there are many options with this axis. The first one is you can make a grid on it. We can make both of them to let you see the grids. After that, there's the reverse button that we are going to make, for example, on the art to have positive values of luminosity going upwards the y-axis. Other than that, there's the top axis and the right axis to move correspondingly the x-axis to the top and the y-axis to the right. And the last one is to make a logarithmic scale. After that, you can choose, for example, the minimum and maximum values of both X and Y columns, if you want to do that. And the last thing is the X and Y ratio. You can specify the ratio between the axes. For example, if I chose 2, it made me stretch or to height or to height or to width, but I'm not going to take that because I don't think it's useful for this time. And having shown all these points, we are just to press OK, and it should create this plot right there. Here you can see there are red squares in the color magnitude with the R axis, which is reversed, and the grids. The last plot that we need to make, this time we can make it maybe a little faster, is the color diagram. How we can make the color diagram? I made a U minus G versus G minus R diagram. So looking at the x-axis, we have G minus R. So you can choose the first one, mag G. copy that, minus Control V. You have to take the G for the R. The y-axis is U minus G. So you search for U, Mag-UC model, minus Control V, G. At this point, we can go, for example, to the symbol. We can make, for example, star. Color, we can make it, for example, orange, no, green. And the chart options are color, and the X label. And if you don't choose the labels on the X label, Y labels, it's gonna show you these ones: Mag-GC model minus Mag-RC model, and same thing for Y. But to make it clear, we can make G minus R and U minus G. We can make also the grid if you want, and press OK. So we have these plots. The first one is a spatial distribution, the second one color magnitude diagram, and third one color diagram. Now, why essentially it is useful to use the portal? It is useful because you can apply filters very quickly and easily by many ways. The first one we are going to see is using the table, and we are doing that in a similar way that we did in the first table when we were choosing the columns of the table we want to work with. For example, if we want only, for some reason, only the points with the right ascension which is greater than 60, we can apply the filter in this window right there. Just to mention, if you don't see these white windows, you have to click on this button, which is the one to apply the filter. If I click on that, it just removes that. Re-clicking on it, it should appear. So apply the filter. You have to take, for example, greater than 60. Press enter, and doing so, you can see very quickly in the first one that we can see only the points with the right ascension which is greater than 60, but also on the two other plots we see only this type of points. We don't see the other points. Or we can see that clearly. We have to highlight all these points. In particular, to see only the points with right ascension which is greater than 60, seeing both these points and the other points, we have to select all of these points by clicking this select button. And you can see that once a point is selected, they become yellow. And remove the filter. So what we are doing, we are selecting all these points that are going to be still selected, but we are removing the filter. So we are going to obtain all the points we had at first. So by clicking this removal filters button, you should obtain this thing. So we have all the points where only the points with the right ascension which is greater than 60 are going to be highlighted, and both on the other axis. To cancel the filter, you can unselect all selected points. Click on this button on the upper right. In this way, you should return to the first part. There's another way to apply some filters to select some data. The first one, as I show you, is by using the table, but you can do that also directly on the plots. Or you can do that, you can use these buttons on the upper right. Just to let you see very quickly, you can do many things. For example, using the pan button, you can just click on the pan button, you can move the plot, and you can do that for all the plots. you can use the zoom button, but the one we're going to work with is the select button, which is also the pre-selected one. The select button makes you create a rectangle or an interval of data that you want to highlight. So if you drag the mouse diagonally, you can make a rectangle of data, or if you move it horizontally, it makes you an interval, in this case of the U- circle or indexes, or vertically an interval on the y-axis. For example, if I take this, it should appear these two buttons. The second one should select all these points, and the first one apply the filter, choosing only these points. For example, if we apply the filter, so using this button, we are going to have only these points right there. And as I said before, this filter works with the other plots too. The great thing about that is that you can see the numerical values of this filter on the table. If you see this MAG RC model, we applied a constraint on the R values, and we have this is greater than 25 and less than 27.9. And we can do the same thing we did before. We can select all these points, remove the filter to see all the points with only this selected. So removing this selection, I can show you the other things that just made you select these points, highlight these points with just one step. I can do that, for example, on the first one to change it. So we have the select button and take, in this case, a rectangle of data. And we are going to take the selected and closed points button. By doing so, we have directly only highlighted these points. So there's another thing I want to show you because I think it's really useful, which is, for example, if you remove the filter and select other points, for example, I don't know, these ones, and apply the filter, so we have only this data as we did before, you can see that on the table, other than having the constraints that in this time are going to be both on the right ascension and declination, we are going to have only, if you can see it, 128 points. Indeed, we have only the points you can see in this plot, and not all them. They were about 1,200 points we have on this query. If you want to save only the table containing only these points, you can press the save button to save it as a table and save that. So you could just reopen the portal, uploading just this file and work just with these points if you, for example, need only these points. You can do the same thing, for example, saving the plots as PNG. You could also save that save the plots with all the data on, but it could be more useful to save only the points with the filter on, or as I said in this the screenshot, to make a screenshot of the points with the only the highlighted points that in this case are the weak line Tauri stars. So you can save that using this button. You have to select the single table once a time. You can see that selecting the plot, it becomes orange on the edges, and you have to save it once a time. And you can do it also on the table. I can show you, for example, how to upload this table on the portal, which is using the upload button. So you're going to press the upload button, choose a file. So you have to download and take the table you had just downloaded. And so you're going to have these columns and click on load table. Clicking on the load table, you can see we have only these points. We have 128. Obviously, we have only right ascension declination because we have to make the other plots, but we have only these points we are selected. Another part is you can see that there are the various projects you are working with. For example, the second one is the one we were working with the tutorial. And the first one is the one I showed you at first, where I selected only the client Italy stars. Now you could see more clearly that I press W, I press Enter to take only the points with this chart with W, and apply the filter, so you can see that. There's another last thing I want to show you is how to see the plots in other ways, essentially. So we can remove the filter. Another thing before that is, for example, if you choose this plot, you can modify the plot. How to modify the plot? You have to click on this tools button, and essentially reopens you the window you compiled when you were forming the plot. You can, for example, leave the grid buttons. You take off the grid buttons, apply that, apply, close, so you don't have more grids. And you can do also, for information, on the table, edit table options. That edit table options made you see the more in depth the grammar of the constraints you can apply using the advanced filter button. You can see here all the grammar you need to use if you want to make more complex constraints. So closing that, I'm going to show you the last thing, which is just how to view clearly the plots. There are two customization you can do with these plots. That is, as you can see, there are these two buttons on the center. We have this one, we show charts as styles, which is the preselected one that shows you the various plots one next to each other. And the first one make you see only the once upon a time, and clicking these arrows, you can scroll between them. Another way to see it even bigger is use the button, the expand this panel. So you have all this page looking at a single plot once a time. And obviously you can apply filters also in this way. You have to press the select, select the rectangle, apply the filters, and so on. And to return to the starting page, you have to press close to return this page. So essentially, this was it. If you have any questions, you can make, if I can have an answer for you. And yes, thank you for your attention. And that's that.
This was an excellent presentation, Alessandro, and I suspect that this will be very useful for people who want to learn how to use the portal. So absolutely,
thank you so much.
I'm really glad we're recording this because this will be useful for future students. So
thank you. It means a lot for me. Thank you.
Yeah, no, that's great. That's really terrific. Okay, at this point, maybe what we can do is, if anybody has any questions to Alessandro, can raise their hand. And with considering the fact that this is a very valuable recording, one of the reasons why I want to keep those of you who are interested in this in the main room is that we can continue the recording. If we were to move you, Alessandro, to a breakout room, then we'll lose that possibility. So let's just go through. If there are any questions, just go ahead, raise your hand. Harry, go ahead. Why don't you start?
Yeah, it seemed like you could do this, but it went by fast. Can you, in the individual plots, can you use a different column or arithmetic to set the colors and sizes of the points than the columns you're making plotting exercises?
Yeah. I can work independently with the one plot at a time, or one plot at a time, and I can modify the colors and highlighted the points and apply the filter. But the filter I'm gonna apply to all the plots you have you have entered with this in this window. If you want to make separate constraints, separate filters on different plots using the same columns, you have to, for example, as I did there, take another window, just take all the table. For example, you can at this point save this table, the entire table, open another window and apply the constraints, the colors differently. But the colors of the single points in the single plots, you can modify them. As I said, there's the red one and the green one. You can change that too.
Yeah, I guess what I was wondering was if I wanted to make the sizes of the points in the color diagram bigger for the brighter objects and smaller for the fainter ones.
You should be able to do that, but I never tried. So we could see that if I tried that, maybe we can try that. Just give me a second. So you have to press the 2 button. We have so just to make it bigger. For you said to make bigger only the selected ones.
No, I just wondered if there was a way to give it a different column to
a different column to only the selected points.
Well, to scale the size. So under the trace options for size, that map, I don't know if that map is a column name. Yeah. So you can give it a column.
Map should, yes, it makes you choose the column name.
Yeah. So that should work. Yep.
Yeah. I never tried it, but yes, it should work.
All right, any other questions? No, I don't see any hands up. So let me just make a breakout room for the for Harry and others, if you want to continue doing that. And let me just do 2 breakout rooms for the time being, and I will set it up in such a way that participants can choose their own room, if that's okay. Okay. So room 1 will be, let me see, what did we call it officially? Was it source injection room? I think that's what it was. Okay, and room 2 will be spur. All right, so I'm going to open all rooms, and those of you who want to go off and work in any specific room, go ahead, or let me know if there's anything else that I could, any more rooms I could add. All right, I don't see anybody else who is asking for another room. So Alessandro, if you would like to continue with some of the things that you consider useful for others, we're continuing to record it. So if you want to just tell us some bits and pieces where you felt that it's, maybe there should be some particular attention people have to pay when they're using Rubinstein's platform and all that, just in a portal aspect.
Yeah. As for the portal aspect, I just said essentially all I know about it, and but for the notebook aspect, I worked with the notebook aspect a lot, and I can show you, for example, how to make these are the ones I show you there, the bokeh plot, the plot with using the bokeh library of Python that made you create this interactive plot. For example, if you see this in my report, I can give you on the chat maybe the link so you can follow me with that.
Sure.
Okay. tell me if it opens to you. There's the first part, so you see if it's okay.
Okay, so if you want to walk us through maybe one of your notebooks or something like this, just to show us the different steps that you're taking, that could be useful if you think that's appropriate.
Yeah. I can show you real quickly the first part of my report that I talked about very quickly in the first part on the presentation, just to let you see what I've done, in particular the notebook, the part of the use of bokeh. The thing that is useful for me is the bokeh, because it lets you create these interactive plots that I never seen before, but before using bokeh. So this is just the first part. I'm going to show you real quickly my report, so just to see what I've done essentially. Just the first part where I show you the topics. This is the young stellar object. It is what I talk about, the classes and the same image, and adaptive variables, ditary stars, and the other skills. So maybe I can go just to the bokeh because it's very long to read. These are the Rubinstein, Stack Club, the use of math, because I also work with the metrics. And if you're interested in how to make a metric, I also made a tutorial essentially, which is this other notebook, the example of the use of math. Also in this internship, there's a tutorial of the use of math, just the first thing you have to use to create, for example, some plots and to take some data out of it. So you can see that. If you're interested, you can tell me. I'm gonna be more in depth about that. But the thing I think it's more important, it's the bokeh one, which is right there. So I'll let you see what I've done in this course. Essentially, make it bigger so maybe you can see it better.
Okay,
so
that is great.
Sorry. So here I defined our repos. There's the first part of the code where I take the data. This is taken from VGR. This is external data. The data used by Bonito 2014 about the classification of stars in NGC 2264. I used this data to make these tables. Here just are the columns of the table with the specified label, format, and so units of the various columns. And after that, here define. There's the part you can follow me better is the part here where I define all the values I need to insert in the application to bokeh. And to use bokeh, you have all these imports. I wonder if you wanted to, I can copy that so we can work that notebook together. But you have essentially to take this data. So maybe I can just for the first part let you see that what I obtain and how to run code using bokeh. So here are all the imports of bokeh, and here I define all the things that I used in this cell, which is essentially the core that made me create these plots. We have at first source selects of the variables that are going to be used. Essentially, as this grammar, we have column data source, and we have to select the data equals, and we have to take the various columns we enlisted before, these ones, URG RADEC, and I define also this U minus G, U minus R, G minus R. And you have to make U equals U, all these equals you have to make. After that, we have the tools, which is the real core of Bokeh. The tools are all the buttons you see in the final product, essentially. All these buttons right there are all the tools. For example, I can maybe let you see that. Okay, in this way. Okay. Okay, in this way we have over, which is this one. Pen, box zoom, wheel zoom, box select, lasso select are all these buttons, and you can see those buttons, those instructions to take all of these buttons in a link of the main page of Bokeh, where explains to you very clearly how to do that, essentially, because I managed to do that mostly seeing that from that. To let you see the final product, you see that we have all of these buttons. I personally took almost all of them, but there may be others that I didn't didn't make to this in this plot because I thought they weren't necessary. We have the first one, which is the pan button. We can essentially move the plot. The second one is box zoom, that made you create this rectangle that zooms the area you're selecting. And for example, you have to, for example, take this refresh reset button to return to the first, to the original plot. The lasso selected is the one that I showed you before, lets you select the data, grabbing this with the mouse. You select this area, and this other one lets you zoom with the wheel and zoom in and zoom out. And this one is always selected. The top one is the one that tapping the mouse made you select the same points in the both three plots, because I made three, but now I show you how to make three or more of them, and I decided to make it horizontally, but you also could make it vertically or in other ways. And there's also the save button that made you save the PNG of the plot as you apply the filter, so with the filter on. And the last one is the over. The over is the one that makes when you move the mouse, gives you information about the point you're seeing. And in this case is this window that shows on the left of the pointer. If you take it out, you don't see any more of that. So returning to that, I can make it full screen. How did I do that? Here's Quarks. Quarks lists some color preferences between the selected and non-selected data. So we have selection fill color red because I make the fill red, essentially. You can modify that. This one should apply to the one that we are not selecting. You can see that if I do that, you can see it better. For example, I can zoom in these points or in the square, which is clearer. And for example, selecting them with the lasso, you can see that even though it's really is very tiny, that selecting them make them red with the other part, which is green. The line color is green and the fill is red. And the other ones that are not selected appear in silver, and you could see that, for example, here. You can see it very well, and they are silver. you can modify the color they appear in this way. All the colors that are available are listed also in this link. And at this point, I can just let you see that link, so you have that also. But I'm going to return to the page. Okay, this is a link of for the bokeh, or the instruction for the use of bokeh. Okay, after that we have the output file, where I'm gonna choose the file where I'm gonna the HTML file of the plot and the title of the file. Another thing, it was very hard for me to obtain to make the plot in the notebook on GitHub. I tried in many ways, but I ended up with just taking a screenshot and leaving the link to access to the HTML file, so you can essentially appreciate the real value of the bokeh library. Also, if you want to open this page where you can apply filters on this data, you have to go to have access to the interactive plot. Just click this link, which is just below this screenshot. So returning to the code, we have this plot. So I call that first, second, and third. Very the first one, I have to say first equals figure. Apply the tools that I call those tools with all capital letters. Plot width, the plot height. We have selected 400 to 400. I can modify that. And the title. After that, we are gonna select essentially all the details of the plot. For example, we have two plots, and the points are going to be circles. The name of the axis are going to be right ascension and declination, and take the source of data are going to be the one I defined there. And this other part made you apply the quirks that are these selection tools that made you modify the color, the selected point, and the non-selected points. Here we can define the ranges of both X and Y axis, specifying the values, in this case, of right ascension and declination. And you can see if you take the greater value on the left, so the first value you enter is the greater one, the second is little. It automatically make the reverse grid, the reverse axis function that it is also in this plot. And essentially you have to make the same thing for the other plots, in particular for the second one, which is the color magnitude. We call it color magnitude. I make it the same size, define the values you're gonna put in it essentially, which is U minus R and R. Remember that I defined those values before, these ones. And after that, here I define only the range of the y-axis. The range, if you don't specify the range on the x-axis or y-axis, it does it automatically. But if you want to take a specific range, you can also apply that by doing so. And this is the label. On the third one is the same thing. Another thing that I didn't mention, the default color of the point is blue, but you can make, you can see that in the second and third one, you have this other option, which is color with this code. This line is specified in the bokeh site, where just it means just a color, this line. For example, this orange, and the third one is red. And on the end, this part is very important because you have to define this function that is the grid plot, so that the one that creates the structure of the plot, the multiplot. And we have to take these, you have to apply first, second, third in this way to make it in just the one row. To make it in 2 rows, for example, 1 row there and another row of plots, if you have more of them below that, you have to take another of that. Second, that I didn't remember one how to translate one thing, so I can show you because I didn't. It is the brackets. Sorry, I didn't remember the brackets. You have to make another bracket, square brackets there. The first one, there are the outer brackets that define all the matrix. It stands for a matrix. This part is a matrix. The first one is the first line. So in this case, I had only one line, so it's just one bracket inside the outer bracket. And if you make another bracket right there, it makes another line. Here you can define, you can choose the toolbar location, which is below. This way, this is the toolbar. You can make it up, right, and left, and below in this case. And this is the theme of the background of the plot. You can make it dark or in various ways. This is like minimally the one that shows the also on the bokeh site. And the last part is show P. P is this plot. You have to show that to have these results. In particular, this is just a screenshot, but it should create something like that just below the codes, where you can work with that just on the notebook. For example, if I go to the notebook aspect that I didn't open, just a second. Okay. I should have this notebook so I can show you. I can change something to let you see these plots.
Alessandro, let me just mention that there is some interest in making sure that you contribute your notebook to the repository of notebooks for the DP0 participants. So I'll let you know later how to do it. Is that okay?
Okay, surely.
Yeah,
obviously there's not
really useful. I think that a young person like yourself, starting, has gone through some of the learning process, which is very useful for other students who will be entering this process. So again, this is very appreciated. But go ahead. Sorry to interrupt.
No, sorry, Greg. If I may, I would like to thank a lot Alessandro. He said in his presentation he's a third-year undergrad student, and this internship was during the first part of the third year. It didn't even started the astronomy course then. So I really appreciate the internship work he has done with me, and I want to thank him again.
Thank you. Okay. Just looking at the notebook, we have, this is just a notebook aspect. This is my report essentially. And if it is working, okay. This is the tables that works. Okay, I have to restart that. This is just a screenshot I made, but here's the real one. So you can see that there's the one I show you there in the HTML file. You can work with that just below the code, so you can modify all the things you want. For example, if you modify this part and take, for example, now we have to remember the third one below. Just okay. it appears like that. Maybe. Okay. This is the screenshot, so don't look at that. It's just a screenshot. And I just show you it is a matrix essentially. The first one is the first line, and you can go so on. For example, you can make a bracket for each one. It will be essentially vertically divided. But if you just take in one bracket, they're going to be, as I did, just in line. You can modify the toolbar location on the right, for example, right there. And the theme, I can go now maybe to the page of Bokeh to let you see all the grammar you have to use. For example, as I said, for the background, but also for the color of the points. For example, now you have to remember where it was. Maybe it was there. Okay. User guide. Okay, it should be on the user guide section. And configuring plot tools. For example, there's above, below, left, and right is the toolbar location. And there are other ways, other things I want to show you. For example, is the color of the points. But on these lessons, essentially, you have everything you need to make these bokeh plots. Another thing I want to just say, because it was very hard for me when I did it on the report. Also, to make this link, it is an HTML file, so you should download that to access this file. But to make it so that you don't have to download the file, I make something a little bit strange. So in my repository of GitHub, I uploaded the HTML file. You can see that internship. There's I call that bokeh appendix report.html. And after that, I upload that to NB Viewer, which is another site that just lets you open the notebooks or the HTML files, but didn't work with just entering the HTML file, because it should be on the online file accessible online. So I made this GitHub HTML file, and I upload that to NB Viewer. So this is on NB Viewer, as you can see. If you were wondering how to do the same thing, because I struggled a lot doing so. And we can modify some things. For example, if you want, I can give you the table of data I used for to make this plot. I don't know if I can enter on the Shatta file you can download. I don't know if it's possible. I'm gonna try. See. No, I don't think I can do it, because just message. Or you have to upload from another part. I don't know to do that. So if you know if it's possible to upload some file, you will say that to me, but it is not needed, because it's just
maybe, sorry, Alessandro, maybe you can share this through the Stack Lab Slack channel, but I don't know if all
Slack okay, I could share that on the Stack Lab.
What do you think, Greg? It is appropriate? I don't know if all in the audience are also member of that channel, and if everybody can retrieve that file.
It's just this external data file I take from VGR, but I don't know essentially how to give you this file to also work with that if you want to work with that with me.
Maybe you can put that table there. And in any case, we also, and Alessandro also mentioned this in the notebook, we have strongly used the knowledge learned from the Stack Lab course using the resources available online. And Alessandro, you also indicated in the notebook, in your notebook, the notebook that we have used for this. If you can show.
Yeah.
There is also a link here.
There's a link I used.
I have seen.
I don't remember if it's
you scroll down the point 6 when you were showing the notebook, I think you refer to.
Yes, and this one. No, this is the Rubin elastic filters. This
This
one,
one.
the Stack Hub course session 3 into Toolbar. This
Yeah.
one. I can open that. Yeah, I worked with a lot of these Stack Hub course files here on GitHub. They helped me out a lot.
As well as the DP0 assembly tutorials available. So Alessandro, in a very short time, used a lot of resources for notebook. It didn't even use the Python before. That's correct, Alessandro?
Yeah. I have a lot to learn about Python yet. I just done the basis part of that, just basic. But yes, I use that.
But he decided, as an example, he decided once started using the notebook aspect, he decided why not doing the report itself or for the internship as a notebook. That's why you can see that on GitHub. So it was his idea to not to prepare a PDF version of the internship report, but to go for a notebook, and within the notebook of the report also to show a notebook for analysis of the data.
Yeah, it is true. And what other can I show you? Because I don't know if I can put the file on the Stack Hub channel on Slack. Do you think I can do that or not?
Gregory, if it is fine with you, if Alessandro shared that table, it is a way to just follow the steps of this notebook tutorial using exactly the same external table. So people maybe can download it and import in the notebook, or otherwise we can continue just with the tutorial. It is a public table published by Laura Venuti.
You can take. I can also leave a link just if I can find it. Maybe just a minute.
In any case, anybody can use their own data sets or DP0 dates, of course, and customize for the plots that anybody is more interested in by following the tutorial notebook Alessandro is presenting.
Unfortunately, I will have to leave now, and I just passed over the hosting to Leanne. But I will watch the recording afterwards. I have another meeting I usually run at 10:30. So sorry about that.
Okay.
And this is really impressive, Alessandro, and I'm really looking forward to not only to watch the rest of this offline, but also to try to play with your tutorial notebook once you put it into the repository. So thanks again. Very appreciated.
Thank you.
Thank you, Greg, for the opportunity.
This is exactly what we like to see in this venue. So thank you.
Okay, I just put on the chat the link from VGR, but you have to follow a few steps to download the file. I also made a tutorial about downloading that, It's on the report here. Before the 6th point is the PDF I made, also my internship. This is just an appendix with how to import the data. This is just a sophisticated data system, how to research some articles. Here's the VDR. So what you have to do if you want to download this file to have the data, you have this link where I give you in the chat, and you have to click on Save in CDS Portal. Make it maybe a little bit bigger. Save in CDS Portal. I don't know if it works. Okay. It makes you save the file in this way. You have to click on Save. And it shows you the file has been successfully uploaded. And at this point, you can go to My Data, and it should appear. Okay, it should appear something like that. And at this point, it should make you download that as a fixed file. I don't remember if I download that as a fixed file. Let me see. Yes, fixed file. So you can download, click on Fix. So you have the file. Okay, it's downloading, but also already have that, but I'm gonna try to download that if see it works, because I did it a few months ago, so I don't know if it still works. Okay. Just give it a little bit of time because it's taking a lot for me. I don't know if it takes a lot also for you. What I can show you in this time, this is the imports. I have to give you also the imports because it's necessary to have that, but maybe you can.
In the meantime, Alessandro, sorry, as you were mentioning before, the use of the colors, different colors for the options. I have tried also in the past by defining just the like red or green instead of the codes. So
it works also like that.
It should work. In the notebook that I have developed some time ago now was like that. So maybe you can try just like saying violet, whatever. It should work in principle. I don't know if.
Okay, let's see. Yeah.
Yes.
It works.
So just in case because you was checking in the bokeh tutorial, but just in case the ones that you want to use like red, green, blue, whatever, even indigo. I have tried also indigo, something like that should work. It is straightforward. So it is a very powerful tool, I think. And for plots, also for analysis, because it's not just like nice plots, but they are not static. So in a sense, if you want to do a more in-depth analysis after your first look at that, you can do even after. So maybe in the notebook that in the GitHub notebook that Alessandro provided, there is this direct link to open these interactive plots, even if you don't have now the tables that Alessandro uploaded. If you show here, Alessandro, the direct link for that, or even if you want to share here.
I share that, it's easier.
Yes,
it's easier, yes.
Share here in the chat. Everybody can just. I see Liana has a question. Of course, Liana, please.
Okay. I didn't. Yeah.
Yeah, hey Alessandro, it's great to see you using bokeh. I'm a huge fan of HoloViz. I love it. I think it's the future. It's the way forwards. I pretty much never use Matplotlib now. That's or I never really did very much actually, to be honest. I don't know if you noticed, but we do have a tutorial notebook that goes into quite a bit of depth about using bokeh and hollow views for interface.
Yeah, I used that. It was the first one I used where I once I started looking for this. Before using the bokeh site itself, I used, and I opened it. I don't remember if it's still open. Yeah, in the session 3 Stack Club course, I used that.
That's the one. Yeah, if you go to the tutorial notebooks though for DP0, you'll find some that are updated and that make use of DP0 data. So it takes a lot of that notebook from Keith is great, but I think he uses a DES survey GDR2 data set in that example. And if you want to see some examples of DP0.1 and DP0.2, you can see it in the tutorial notebooks for DP0.
Okay. Can you leave me the link about this DP0? Because
you're not familiar with the tutorial notebook. Maybe I could ask Tina to just paste a link to the GitHub repository for the DP0.2.1 tutorial notebooks.
Okay, will do.
okay, thank you. Yeah, so I worked with that about November, December 2021. I don't know if there were updated notebooks, but I just saw the Stack Club course once, and I work straight up with those. And after that, I have some other in-depth information using also the link. The bokeh link, I use that only for the colors, these more specific codes you have to use, not just the up below. This is intuitive, but other stuff also to make it in one line, all this stuff like that. But to start,
it's really nice, and you know, I find the bokeh user guides quite useful as well, very helpful.
Yeah, it was also for me, obviously. So this download, I don't know if it works with you, also for you, this download of the data, but you should be able to see the HTML file that the last thing I uploaded in the chat. Others there will be DP0 tutorial. Okay, thank you. So into two.
If you look at notebooks 8A and 8B, they give you some more examples on interactive catalog visualization and image visualization. So it also shows you how you can use bokeh with plots, with images, frames, science images that you get from the butler to start to LSST data. And they're very much based on the tutorial notebook that Keith wrote for Stack Club as well.
Okay.
Goes into more DP0 data.
I don't remember if maybe I saw these ones, but it was on the last part of the internship, so I already finished it. In particular with the DP0 using them into the DP0 notebooks, so the first ones, also into the Butler, but I ended up not using it, but I looked for that. But as regards the bokeh one, I pretty much studied with the Stack Club. I didn't see that there was this other ad because it is 15 days ago. Okay, I worked with that a few months ago, so here's why. So what other things I can show you? I worked also with the metrics. I just used that in the first part to have familiarity with the notebooks days of Python. I started using Python with the metrics essentially, and it was just a start for me to just start looking at these things, and after that to apply the knowledge, the basic knowledge of Python to bokeh, so the notebook, can make a comparison, because it was in the end the focus of my notebook was about the comparison between parallel ways to see a problem, which is the use of the notebook and the portal gives two parallel or complementary views of the same thing. And the one I use the most is the notebook, or to be more precise, that gave me more in-depth information. But also the portal was very useful. It is true that I imported data that already determined the weak line theta restars, but I use that just to select these points and to have a comparison with the other one. Other things that I can show you is all the imports. As I said, you could also do the same thing. I could, it is already, I already gave you my GitHub, so I created this last part of the of my report to be so that everyone is able to recreate the same thing, having access to this file essentially. But you should be able to, because I gave you this MBViewer file, and there's also this other file I made, the PDF one, if I can find it, is one that just shows you how to upload the file on the portal, for example, because this is the plot I used on the portal, is the first one I used, with the classification between classical theta stars and weak line theta stars. And there's also a much easier and with less things that the ones I said now, but there's a mini tutorial about the use of portal. I did it while I was taking my internship. Now I said many more things, but I already wrote that. So if you want to see that just for the basics, you can also do that. So if you want, if you don't have any questions or things you want me to talk about more in depth about my internship or my internship report, I could talk about the metric analysis framework and the basis of the metric analysis framework. That is just what I know about that. So if you want, I want to talk about the math because it was very useful for me, and also to better understand all the LST architecture. There's a lot of things that starting the internship I didn't quite understand very easily, but seeing the tutorials, the DP0 tutorials also from YouTube, I saw a few of them at the very start, and with all these tutorials, in a few months, it is possible to understand at least a general view, to have a general view of how this works, of the aspects of the Rubinstein platform works, Portal notebook, because I worked with them, and also with the math. I also was starting to try to create a new metric, but it was too much stuff to do in 2 months. So I decided to go with the use of Portal and notebook. It was better for the time I had, essentially. So I can talk about the math because for me it's very useful, and we are going to talk about
I can say, Alessandro, sorry for interrupting you. I can say that even if this is not focused on DP0 data, we are now within Rubin LSST working on the optimization of the survey strategy. And this was the metrics we have to provide in the last month was for us very important. So this is the very first steps for the math work. And so I think it was, as you were saying, I think it was useful for you to learn. And yeah, I don't know if it can be of interest for anybody, you can continue on that for my side. I don't know.
For me, it is useful because I started working with that, with the metrics, before attending to the COC, where the metrics are essentially applied. And if I didn't understand the metrics, I couldn't understand anything about a COC meeting. So I can talk about these metrics. So we have to access to the OPSIM. OPSIM is the operation simulators, is the simulated data that essentially we are working with before the start of the real data, the very Rubin real data. And the matrix, what does? I tried to simplify it as much as I could what math does. So the first part is that gives you an access to the operation simulator. So it gives you access to the data. After that, you can query the data. So you can apply filters, constraints. And another way, you can slice it. So you can take one precise part of the data you're interested in, or create a group of data samples. So you have to take, because you can slice the data also not only in spatial, within a spatial constraint, but also temporal constraints. So you can, for example, specify what you want the frequency of samplings to be. If you want, for example, study classical T-Tauri stars that was have accretion disk and accretion effects, they will have a very high emission variability that can be detected only if you have a certain frequency of the data you take, or if you are interested in something that has a less variability, or a variability that happens, for example, in years, you maybe are interested in just a few data taken per year or per month, depending on what you're working with. And I thought that it was very useful, in particular for the survey, the optimization of the survey, because all this idea of the optimize, the fact that how to use the telescope, how to give the telescope to many science collaboration, depending on what they need, they have to find the best way to have access to all the data and use at the maximum power the telescope. It is very hard. I don't quite understand practically anything about how to decide the frequency of the data you have to take and why, but I imagine that it's very hard to choose how to take that. But for that, the metrics are very useful, because you can see, using the metrics, you can see why you should see a specific zone of the sky, and why some periods rather than others, or with various frequencies. So what math does, so slices the data, and at this point, once you have the sliced data, you can make statistical analysis with this data. You can work with various principal slicers in math. There are many others, but I show just the major tree, which is a unislicer that just gathers all the data in just one group. The one slicer, which is the one I personally should use the most, just groups the visits depending on just a constraint you apply. And the other one is the LPix slicer that groups in base of a given field pixel. It is just a place of the sky, a region of the sky you define and slice the data within these field pixels. So how should be a typical Mac workflow? So how to create the codes for the use of MAF? It should have the metric bundle and the metric bundle group. What is the metric bundle? Is the main function, the core of the metric, and it comes from in this way. Metric bundle, we have metric slicer and SQL constraint. The metric just specify all the computation you have to take on this data, on the selected data. The slicer is, as I said, how to slice the data, what part you are interested in. And the SQL constraint is just the constraints, so the limiting, applying some filters, apply the data you are querying. The metric bundle group is, as I said, a dictionary or a group of metric bundles. So you may define various functions, various metric bundles, and apply all of those metrics in just one database, and work together in this metric bundle group. As I said before, as I showed you before, there's a PDF, not PDF, but an HTML file I made about the basics of the use of MAF. I can show you that, not too in depth, but because maybe it's not good to see a lot in depth, but just to see the concept about it. And here's a reference about that, the MAF tutorials notebook, introduction to MAF. I also saw that on GitHub, ST Rubin Sim notebooks. I studied from that, and I derived a more synthesis of what I saw that, and just the part I was interested in, because it can go much deeper than the thing that I understand than the ones I studied. As I said, you can also create a metric, so define the function you want to work with, but I didn't arrive to this point. I just use the metrics, the general metrics that are accessible, and worked with that, combine those metrics to create a metric bundle. So here's just an example to show you how should be the lines of code you have to make to create a metric bundle group. So here's all the imports. As I said, I don't want to go all the way through these imports. And if you want, you obviously can see that there's a link in my report. The link is in the last part of the report, this part right there. Before the 5th point, and Rubinstein platform is this one, the example of the use of MAF. And so here's all the imports, and this I was specifying that I would use this kernel. So it's not an up-to-date file. I made it on the first days of January, and so I don't know if maybe it is there are new stuff you can work with, but at the time I was working with that, I used the latest available. So we can define now, for example, a metric. So I define metric 1, the metric as I said before, we have the metric bundle group which contains metric, slicer, and constraint. For example, we can choose the metric that gives the maximum values between the data in the slicer of their mass. How do I know how to write that? Essentially, I took it from this link, which gives you all these, not all, but many columns, many metrics that are available. Okay, it didn't work. So maybe it's not available now. You can access that right now. I have to rewrite that. So, but essentially there was air mass, there was other stuff. Essentially, it counts it gives the values of air mass, and you take the maximum values, the maximum value of that, and this is the application of the metric. Essentially, the metric itself is a function that applies some data, and you have to tell the metric what to do with that. And this just takes the maximum values of air max in the slicer. What is the slicer in this case? I choose the LPX slicer, the one I showed you before, this one, the LPX slicer. So it shows only the L pixel with north side 64. So I defined a specific L pixel well I want to work with. And after that, we have the SQL constraints, and the constraint applied is just to select only the data with the filter I. In this way, as I said, we can make the metric bundle. So we have the metric bundle that I called AirMass Sky, which we can define in this way: metric bundles dot metric bundle, and we enter the metric, the slicer, and the constraints. At this point, I defined all the data, all the file paths of the file I have to take, download, and where to upload the results. We have the root and the field, and the file to where to import that. You can use this kind of this kind of code if you want to take more. For example, in this case, baseline. We have you will use another baseline, another version, and work with many baselines at the same time. For example, naming another database file we want to work with, and apply all of these codes, but with other files. And OpsDB is the database that I define in this way: DB root plus DB file that I defined before. And after that, I have to define the output directory in the same way, essentially. At this point, I defined another metric bundle to show you that, as I said before, to create a metric bundle group, we can, the metric bundle group is a dictionary of many metric bundles that can work together. So I made another matrix, another metric. In this time is account metric, which just gives the accounts of the observations in a place of the sky. And the slicer in this time is the 1D slicer. The 1D slicer is the second one I showed you before, so that counts visit depending on the parameter. So the parameter is night. No, this is how I called it, night, and the bin size is 30. So bin min is 0, bin max is 10 years. So what I've done here, the bin is the night, the single night. The bin size is about 30 nights, so 1 month. And I start from 0 to the 10 years of the survey. So I can take a value of the count of observation for every month. So I have a value of the observation taken every month. Here I define the metric bundle and visits night, where this defines as metric bundles, dot metric bundle, define metric, slicer, and square constraint. So as we can see, is defined by that. And at this point, we can define the metric bundle dictionary, metric bundle group, sorry, which is also called the dictionary, containing the first one, Irma Sky, and the second one, and visits night. I called it this way, referring also to the they were called in a similar way in the file I used to study that, to study the metrics. At this point, I defined the group, the metric bundle group, containing this dictionary. I called the bundle dictionary, and containing the database, the output directory, and the results database. At this point, I have to run all and plot all. So I can see the plot. This is the plot of the max air mass in function of the slicer, LPX slicer. It also gives you the first metric, the area in function of their mass, and this other plot is comes from the second metric bundle, which gives you the count of observation per month. So you can see the various observations per night. In the end, so we have the plot, but we can also access to the data produced by these metrics. It saves a lot of data, the metric bundle group, and we can work with that using the metric values. I just talked about the metric values just in the end, but you can do a lot of things with that. You can access to the numerical values that the simulation gives you, and here's where you can pretty much work with that. But for example, I just show you, for example, to print with the number of visits per 30 nights, and to print that we have to take then visits night metric dot metric values. The same thing for the Irma Sky, the maximum values of Irma Sky per 8 peaks. So we have all these points that refers to these ones, and also in the other one. So this is it for this part of my appendix tutorial. As I said, in the report, the main report I made, I wanted to list all the things that I learned during my internship. There were a lot of things eventually in these 2 months that I learned, and I just wanted to write that down, so I in the first person I can remember what I learned. So I have also the tutorials. So if I don't remember what I've done, for example, the metrics or the how to import the data, I can see it from there.
Let me add that I think, I hope this can be helpful also for other students to use what you have prepared in your internship as a tutorial.
Yeah, Alessandro, this is just great work. You've done so much really good work. It's great to see. We're really lucky to have such delegates and such a community of people like you who are enthusiastically using our tools and services and not only doing good science, but also helping us to understand how you want to do science and helping us to develop the right sort of services and tools and deliver the data products that are necessary to enable this science. So this is really in the spirit of the whole data preview program, in that you get to start doing science and working early, and we get to learn how to make our services better so that we're ready for real data when it comes up with the data releases. So this is great to see. We're actually at the top of the hour now, so we have to wrap up. But I've just really enjoyed following through this. I think this has been discussed already in the chat, but can I ask you to coordinate maybe with Tina, who's here, Tina and Douglas, who are both on the community engagement team, to make sure we're able to get copies of either get copies of this or make sure that your work is linked into our tutorials or our notes or whatever the best way possible is. Tina, could you take point on that?
Yes.
Thank you. Maybe I could just ask for any final comments from people before we have to wrap up. Any final questions or comments?
Alessandro, you amaze me.
Yeah.
Thank you.
Yeah. I'll just
Thank you so much.
lots of claps.
Do you think that I can stop sharing so I can see you in the main screen?
Stop sharing. Great.
Okay.
Yeah, I like that you've done work with MAF as well. In fact, I've started to, I haven't used MAF so much, but I've started to work with it recently. And then it's great to see those examples too. It's great to see that it's serving the purpose as well of helping the science community to, in fact, to understand the cadence proposals and to give us feedback to not just that you've been able to use it, but you've been able to, come to good insights and give that feedback to us about the cadence to help us to make sure that the LSST cadence is right and is as optimal as it can be. As Jelko says, minimizing unhappiness is the goal of the survey cadence. We can't be optimal for dark energy and solar system and variables. That's just not possible. So we have to minimize unhappiness. That's the strategy with our survey cadence optimization.
Yeah, in fact, I realized that it is a really hard work. I don't, as I said, know anything about how to do that, but just thinking about it, I don't think I could make it. So I think it's very hard to decide to minimize unhappiness, as you said.
It's been a long process of many years. I think that the simulations group have put together a great set of tools to help the community, and we've had great input from the community. So we're really grateful for that as well. Okay, well, I see people are starting to drop off. Thank you again, Alessandro, and look forward to seeing everyone at the next delegate presentation or at Stack Club.
Thank you for that, everybody. See you.
Thank you. And thank you for the opportunity for the organizers. Thank you.
Thank you for being a great supervisor as well. Bye.
Thank you.
Bye.